We're looking at solving radical equations algebraically. So here are the steps to solve them. So whenever we have a square root in our equation with an equal sign, we want to get that radical by itself first. So sometimes it might be all by itself. So here's an example. Square root of x plus 1 equals, say, 5, right? That square root is all by itself, right? This whole thing is underneath the radical. There's nothing being multiplied by it, nothing being added to it. So the other circumstance might be, say, 3 root x plus 2 equals, say, 7, right? So here you would have to divide both sides by 3. Then the radical is by itself. Okay. Another example might be, say, negative 2 square root x minus 3 equals 12, right? So here you would have to add 3 first, and then you would go ahead and divide by negative 2, like that. And now the radical is by itself. So that's the idea of isolating the radical. Okay, getting that square root or cube root or third root, fourth root, fifth root, whatever, by itself. So the second step is to eliminate the radical. We just raise it. So square root, we just raise it 2 squared. So then this side we would square. All right. If it's a cube root, then we're going to raise it to the third power. So then we raise this side to the third power. If this is a fourth root, then when we isolate it, get it by itself, we raise it to the fourth power, and then we take whatever this answer is and raise it to the fourth power to get rid of it. Okay, and then the very last thing is just to isolate the variable, whatever variable you're dealing with, get it by itself, solve it, and then plug it back into the original, because we know we can't take a square root of a negative, or we can't take a fourth root of a negative or sixth root of a negative, so we go back in and check to make sure we didn't get any negative answers.